Welcome to the Deep Dive. We're the place you come to get past the headlines, really understand complex topics, and basically pull out the insights you actually need. Today, we are diving deep into something huge unfolding right now, the electric vehicle revolution, the EV shift. And look, this isn't just about, new cars or cleaner air. It's probably the biggest change in transportation we've seen in, over 100 years. It's a total rethink how we move, how we fuel up, even how we fix our cars. But underneath all the excitement about new models and charging stations, there's this massive challenge. It's really critical to making this whole thing work. All this rapid change, fueled by billions from the government, it means we need a whole new workforce, like a highly skilled workforce, and we need them fast. So the big question we're really tackling today is, how on earth do we train millions of workers quickly for these brand new, frankly, high stakes technologies? And crucially, how do we do it safely? It's a massive ask.
Yeah, that's exactly what we're getting into. We're going to explore a really innovative solution that's tackling this head on. People are calling them spatial AI training platforms. Basically, think about combining immersive tech, extended reality or XR, with smart adaptive AI artificial intelligence, using that combo to completely change industrial training. And this isn't just some future idea. It's actually proving itself right now as maybe the answer to this huge national workforce shortage. It's changing how we get people ready for this electrified future.
Okay, so our mission for this deep dive is pretty clear then. First, let's really wrap our heads around the scale of this EV workforce problem. How big is it? Then we'll get into how this spatial AI stuff actually works for EVs dealing with the high voltage risks, the tricky battery tech, all that complexity. And finally, let's look at the proof. Is it actually making a difference? We'll check out the real world impact on safety, speed, costs, basically giving you the key insights into where industrial training is going. All right, let's unpack this because this is where it starts to get really interesting. So let's start with the why. Why this huge rush? Why is the workforce crisis hitting now? It really feels like a perfect storm, doesn't it?
It really is. You've got several big things hitting all at once. First, there's that massive federal investment. The big one is the $7.5 billion from the Infrastructure Investment and Jobs Act.
Right, the NE's program is part of that, isn't it?
Exactly. The National Electric Vehicle Infrastructure Program, their goal. 500,000 public charging stations across the country. Just think about the manpower needed for that alone.
500,000 chargers.
Wow. Yeah. Then you add on states bringing in their own zero-emission rules, pushing automakers and drivers towards EVs. And of course, you just see more and more people wanting to buy EVs. Consumer demand is really taking off. So you put all that together, and boom, you get this sudden, massive, totally unprecedented need for people who know how to build, install, and fix all this new tech.
And the scale. You mentioned the scale is startling. Can you put some numbers on that? How many workers are we talking about?
The projections are pretty eye-opening. By 2030, so not that far away, the U.S. is likely going to need about 1.8 million additional workers just for the EV sector.
1.8 million additional.
Yeah. Additional, yeah. And that's spread across manufacturing, building and the charging network, and the whole service and repair side. If you break it down, maybe 400,000 manufacturing specialists. Think battery factories, car assembly lines. Then maybe 250,000 technicians for the charging infrastructure. These aren't just simple plugs, they're high-power systems. And then a huge number, maybe 300,000 EV service techs for maintenance and repair, keeping all these new cars on the road. It's not just a number. It means fundamentally retraining and upskilling a massive chunk of our industrial workforce.
That's right. Okay, that's a lot of people. And that 1.8 million figure, just to clarify, are we mostly talking about retraining folks who already work in automotive, or is it more about bringing in totally new people? What's the main skill shift here?
It's definitely a mix.
No.
But a huge part of it has to be reskilling and upskilling the people we already have, alongside attracting new talent, of course. The fundamental change is huge. Mechanics have understood internal combustion engines for, like, a century, right? Now suddenly it's high voltage DC electricity, really complex battery chemistry, sophisticated software running everything.
It's a completely different world under the hood.
Totally. It's not just swapping parts anymore. It's a whole new way of thinking about how vehicles are powered and controlled. The knowledge gap is significant.
And it's not just the numbers or the knowledge gap. You mentioned something earlier, and our sources really flag this too. Safety. There's a stat that says 8.5 electrical incidents per 1,000 EV workers each year, which is, what, 3 times higher than traditional auto work?
That's right. 3 times higher.
That's genuinely concerning. You think about the human cost there, potential for serious injury. So what does that mean for worker safety as we make this big push? And how do we even start to reduce that risk when we need millions of people doing this work?
Absolutely. The stakes are incredibly high. And what's really fascinating and, frankly, a bit scary is that the old ways of training just don't cut it. They really can't safely or effectively simulate these specific dangers and complexities. We're talking about DC electrical systems running up to 1,000 volts. That's lethal potential right there.
Okay.
Then you've got these advanced battery technologies. They need very specific handling, not just because of the power, but their chemical makeup.
Mm-hmm.
You mentioned thermal runaway earlier. That's when a battery basically overheats uncontrollably. It can lead to fire, intense heat.
Right, like an internal combustion inside the battery itself?
Exactly. Learning how to prevent that or deal with it if it happens, trying to teach that safely in a traditional setting is incredibly difficult, maybe impossible. And even the charging stations themselves, they combine serious power electronics with communication networks. So technicians need both electrical skills and IT know-how. These aren't just new gadgets. They bring entirely new, serious risks. Trying to teach that in a classroom or regular workshop, it's either dangerous or you need incredibly extensive specialized gear that you can't let trainees easily break.
It really sounds like the old playbook is just obsolete for this challenge. The scale, the speed, the danger, it's too much. So if the old ways don't work and the stakes are this high, what is the solution? This seems to be where companies like EON Reality are making a difference. You mentioned their platform uses XR tech combined with AI, artificial intelligence, to create training specifically for EV safety and skills. It sounds almost like science fiction. Is this actually practical and scalable today, or is it still kind of an early adopter thing?
No, it's definitely scalable, and it's being used right now. Think of spatial AI, like having a super smart virtual mentor who's always there, guiding you through realistic situations. It's not just a video you watch. It's an immersive world you step into. It reacts to what you do, tracks your performance, and adjusts the training just for you, all while keeping you completely safe.
So it adapts to the individual learner.
Exactly.
Right.
And the capabilities directly tackle those dangers we just talked about. Let's take high-voltage safety simulation. Technicians can literally step inside a virtual environment and practice extremely hazardous procedures. Things like disconnecting high-voltage lines, finding an electrical fault. Tasks that carry real risk in the physical world. Here, they do it with zero exposure to actual lethal voltages.
Wow.
They build muscle memory for critical things like what to do in an arc flash where electricity jumps through the air, or the lockout steps needed to safely de-energize equipment before working on it, even emergency responses. All practiced safely, repeatedly, until it's second nature.
So they're actually doing it virtually, not just reading about it? That feels like a game changer for safety training.
It is. Then you have battery technology, digital twins.
Digital twins, like a virtual copy.
Precisely.
Right.
Exact. Physics-accurate virtual replicas of these complex lithium-ion battery systems, their cooling systems, everything. Imagine a perfect clone of a real EV battery, but it exists only in the virtual space. You can simulate failures, like that thermal runaway scenario we discussed.
And practice putting out a virtual fire without any actual danger or cost.
Exactly. Practice fire suppression, understand how heat spreads, all without risking real, expensive hardware or anyone's safety. It's like having an infinitely reusable, perfectly realistic practice battery. And for charging infrastructure training, technicians work with complete virtual charging stations. They can practice installing, setting up, testing, and maintaining both the common Level 2 AC chargers and the big DC fast chargers, wiring connections, power distribution, even the network setup, and diagnosing communication issues.
Okay, covers the whole process.
Yeah, and it extends to the electric powertrain simulation too. Interactive training on assembling motors, understanding of the power, electronics inverters, controllers, running diagnostics, all using these accurate virtual models that behave like the real thing.
That covers a massive amount of technical ground. But you also mentioned AI-powered personalization. How does that part work? Is it just making things harder or easier?
Oh, it's much smarter than just adjusting difficulty.
Yeah.
The AI is constantly watching and analyzing how each person performs.
Mm-hmm.
Where do they pause? What mistakes do they tend to make? How quickly are they picking up a specific skill?
Got it. It learns the learner.
Right. And based on that real-time data, the AI tailors the experience.
Yeah.
If someone's struggling with, say, a tricky diagnostic step, the AI might offer more practice on that specific thing, maybe break it down differently, or provide targeted hints. If they're acing it, the AI can speed things up or introduce more complex challenges sooner. Connecting this back to the bigger picture, that level of personalization is really the key. It's what makes rapid, effective skill building possible when you're talking about training millions of people. It ensures everyone gets the support they need, but nobody's held back unnecessarily.
That's really powerful, moving past that old one-size-fits-all model. Okay, so the technology sounds incredible, but how is it actually doing out there in the real world? What are the results? Are companies seeing tangible benefits? What happens when this actually gets deployed?
Yeah, the results we're seeing are really backing up the potential. Based on how companies are rolling this out, focusing on key areas first, the data looks quite strong. For safety certification and compliance, for instance, using immersive training for high-voltage safety, it's shown to cut electrical incident rates by about 60%.
60%, that's huge given the risk.
It's massive. And it's not just about fewer accidents. It helps ensure everyone meets those critical safety standards. NFPA 70E for electrical safety, OSHA regulations, SAE guidelines. That protects workers and reduces company liability. Then, in manufacturing, on the assembly lines, using these digital twin environments for training has cut assembly errors by 35%.
Better quality control right from the start.
Exactly. And it's reduced the time it takes to get new employees fully up to speed by 40%. So safer, more accurate production, and people become productive much faster. And for the existing workforce, those service technician upskilling programs we talked about, they're seeing about an 85% success rate in transitioning mechanics from traditional cars to EVs.
That's a great number. It shows it's possible to bridge that knowledge gap effectively.
Definitely. They're getting the skills they need quickly and confidently, and it doesn't stop there. The platform's also being used for advanced EV tech integration, training people on what's coming next, things like wireless charging, vehicle-to-grid systems where cars can feed power back to the grid, even autonomous driving features in EVs.
So it's about future-proofing the workforce too, not just catching up.
Precisely. Keeping them ahead of the curve.
That's impressive impact across different areas. To really make it concrete, let's look at that before and after comparison the sources provide. It really highlights the difference. Okay, time to competency. Traditionally, getting an EV tech fully proficient takes, 18 months?
About that, yeah. It's a long ramp up.
With Spatial AI, it drops to just 7 months. That's a 61% reduction. You're cutting training time by more than half over a year faster per person.
It's a massive acceleration, especially when you need to scale up workforce numbers quickly.
And the cost. Traditional training averages around $96,750 per technician. That sounds incredibly high.
It reflects the specialized equipment, safety protocols, instructor time, potential damage. It adds up.
Spatial AI brings that down to roughly $32,958. That's a 66% cost reduction. We're talking potentially hundreds of millions saved across the industry just on training costs.
Huge savings. And remember safety.
Right, the incident rate. From 8.5 electrical incidents per 1,000 workers down to 3.4, another 60% reduction.
Safer work environments, fewer injuries. Plus, you get benefits like unlimited virtual practice on high-voltage systems with zero actual risk. And you can deploy the training anywhere. Techs don't all have to travel to one specialized, expensive facility. The training happens where the workers are.
Distributed and accessible. Makes sense.
And if you zoom out, look at a typical EV company, maybe with 1,000 employees needing this kind of training. The total annual benefits from using Spatial AI can be over $29.5 million.
Wow.
The numbers show a first-year ROI somewhere between 2,400% and nearly 3,700%.
That kind of ROI is almost unheard of.
It is. And the payback period. Just 2 to 4 months. The system pays for itself incredibly quickly, which, as you said before, really flips the question. It's not just, can we afford this?
Yeah.
It becomes, what's the cost of not doing this in terms of safety, efficiency, and just staying competitive?
Those numbers are really compelling. It makes a strong business case. But, for a company considering this, what are the typical pushbacks? Are there hurdles to adoption? And how does this platform help overcome them?
That's a fair question. Often the initial concerns are around the perceived upfront cost, or maybe the hassle of integrating a new technology platform. Seems complex, right?
Yeah, you could see that hesitation.
But that incredibly fast ROI and the short payback period, that directly tackles the cost concern. It shows it's financially sound almost immediately. And regarding integration, EON Reality's platform is actually designed to be pretty flexible. It can run on various devices from standard tablets or PCs right up to advanced VR headsets. So it doesn't necessarily require a massive, disruptive overhaul of existing IT.
So it can meet companies where they are, technologically speaking.
To a large extent, yes. And the AI personalization actually helps with adoption too,
Yeah.
because individual workers and their managers quickly see real, measurable improvements in skills and understanding. That builds buy-in fast. It sort of proves its own value very quickly, easing those initial worries.
That makes sense. Okay, let's widen the lens a bit. Talk about the strategic market opportunity here. This isn't just a training tool in isolation. It feels like it's perfectly timed with everything else happening.
Oh, absolutely. It's aligning with these huge trends. The federal money pouring into EV infrastructure, the state mandates pushing adoption, the general industry expansion. It's positioned to really enable that growth, not just react to it.
So where do you see the key partnerships and market segments?
Well, definitely automotive OEM partnerships. Think integrating this training deeply with the big players, Tesla, Ford, GM, Rivian, and others, embedding it into their standard procedures for dealerships and service centers worldwide. That ensures quality and consistency.
Standardizing the training across their networks.
Exactly. Then, crucial alliances with charging network operators. Companies like ChargePoint, Electrify America, EVgo, supporting the technicians who are installing and maintaining literally thousands of those stations. That's key for reliability. Collaborations with educational institutions are also vital. Technical colleges, trade schools, building that pipeline of talent right from the start, getting EV skills into the curriculum.
Preparing the next generation.
And, of course, aligning with federal and state programs. Tapping into that Department of Energy funding, that's $7.5 billion, and Department of Labor training funds, about $3.2 billion annually. That helps make large-scale implementation feasible across the country. So the main markets are pretty clear. EV manufacturers, charging network companies, car dealerships, electrical contractors who are moving into EV charging installation, and definitely the technical schools and colleges.
And what are the most immediate needs it's filling right now? Like the low-hanging fruit for implementation?
Right now, the big ones are definitely the high-voltage safety certification that's table stakes for anyone touching these systems. Also, battery manufacturing training. As more gigafactories come online, charging station installation training is huge given the EVI rollout. And, as we've discussed, that essential upskilling for traditional auto techs making the switch to EVs. Those are the critical bottlenecks this technology is addressing today.
Makes sense. Addressing the most urgent pain points first.
And it's worth remembering, EON Reality didn't just pop up yesterday. They've got over 2 decades of experience in XR and simulation. They've channeled that expertise into building what is arguably the most comprehensive spatial AI training platform for the EV sector specifically. It reflects a bigger commitment, really, to making advanced training accessible, especially in industries going through rapid change.
It's about democratizing that complex knowledge safely. Okay, so let's bring it all together. What does all this mean for you listening and for the future of this whole EV revolution?
I think the core takeaway for me is that this spatial AI training, it's not just a nice-to-have efficiency boost. It feels more fundamental. It's actually critical for safety in this high-voltage world. It's critical for getting millions of people skilled up fast enough. And it's critical for the economic growth we expect from this industry transformation. I mean, just think about the logistics, training millions for jobs that barely existed 10 years ago. This tech seems to make that feasible.
I agree. The really critical point is seeing how technology like this can bridge enormous skill gaps safely. How it can take tasks that are inherently dangerous and complex and turn them into learning experiences that are accessible, safe, and genuinely effective. Ultimately, it's about empowering millions of them to participate safely and productively in the future of how we move, making sure progress benefits everyone without compromising safety or opportunity. So here's a final thought to leave you with. As we race towards this electrified future, how else might this blend of immersive tech and personalized AI change things? We've seen its power in the EV sector, but what about training across every industry facing rapid technological shifts? What could this mean for your own field or your own learning or the workforce challenges you see around you? Something to think about. Thanks for joining us on the Deep Dive.